Hello, my name is Kirby Steckel, and I'm going to be presenting my research called Illuminating the Space of Beatable Load Levels Produced by Various Generative Adversarial Networks. The motivation for this research is that previous work showed that video game levels can be generated by generative adversarial networks. However, the structure of some games makes it difficult for GANs to produce beatable levels. Lode Runner is difficult because there needs to be a path that is traversable to every gold within the level for the player to be able to beat the level. If there are missing ladders, ropes, or ground tiles, it can make even a simple level unbeatable. Now to get a little more into the Gan Training itself, the top left is the original tile-based representation from the game. The top middle is the video game level corpus representation, where each tile corresponds to a different character. On the top right is the JSON form of each level, where each character from the video game level corpus representation corresponds to a one-hot encoded integer. Once you have the JSON form, you can create your training set and start training your GAN. Training starts with passing a randomized latent vector into your generator. The generator generates a level, and the discriminator's job is to tell if that level is real or generated. While this is happening, the discriminator is also being passed levels from the original training set. When the discriminator can no longer distinguish levels from the generator and levels from the training set, training is complete and the discriminator can be discarded. Here is all 150 levels from the game. We trained 6 different GANs, one from the first 5 levels, one from the first 20, 50, 100, all 150 levels, as well as the words present GAN, which is trained on all the levels that represent words or letters. We used Map Elites, which is a quality diversity algorithm to evolve the latent vectors for these GANs. The dimensions we used were the percent ground, the number of enemies, and the number of treasures. The fitness was calculated by the max of the A* length and the connectivity, where connectivity is the ratio of reachable tiles for the agent throughout the level, which is between 0 and 1. When a level is unbeatable, the A* length becomes -1, so connectivity will always be greater in that case. These experiments are also over the average of 30 Map Elites runs. As you can see from the plots on the left, the on 20 levels generated the most beatable levels as well as the highest percentage of beatable levels. And as you can see from the plot on the bottom right, the words present GAN generated the largest variety of levels, although a lot of those levels were unbeatable. Here's the heat map created by the Map Elites archive. The colors you see, the dark ones represent unbeatable levels and the light ones represent beatable levels. Each column in this heat map corresponds to a different GAN. Each row corresponds to a different range of ground percentage. So in this highlighted region here, all these levels have 0 to 10% ground. Within this highlighted region here, as you go higher up, there are more treasures in the level. As you go farther to the right, there are more enemies. Each one of these colored boxes within this highlighted region corresponds to one level. As the experiment persists, if a level of higher quality fits into the same bin, then the level of lower quality is replaced. As you can see, these results correspond to the plots we saw earlier, because the on 20 levels has the highest amount of lighter colored boxes, while the words present has the highest amount of dark colored boxes. We also discovered that the GANs produced 3 distinct different kinds of levels. The first was direct copies from the game. The second was levels that merged elements from 2 or more different levels together. And then there were chaotic or seemingly random levels where there were a lot of misplaced blocks or missing blocks altogether. I would like to thank the SCOPE program of Southwestern University, which allowed me to work with my faculty, Dr. Shrum, as well as providing funding. Thank you all for listening.